So this is pure math topic 2.2, applications of exponential and logarithmic functions. Here we will study inshallah about how we can use this exponential and logarithmic functions to find the population after a given time t, and what will be the growth of a substance after a time t, or if it is there is a decay, then how much substance will be there after a time t, like this. So here there are four formulas, 1 2 3 4, as you see. The first one, if we find doubling time in the question, then we apply this rule, where here the d is doubling time, d doubling time, and the p naught is the population at the beginning, that is at the time t equals to 0, and p will be the population at the time t after a time t. And if there is a half-life in the question, this word, then we use this rule where h is the half-life and a naught amount of the substance at the time t is 0 at the beginning, and amount at the time after time t, that is a. Here there is a sign of plus for a doubling time, and here minus. This difference you can observe. And if there is a exponential growth, just growth but no doubling time, then we use this rule. And if there is a decay but there is no half-life in the question, then we use this rule. So this is the first example. Here we see the half-life is given in the question, so immediately the rule will be a is a naught 2 power minus t over h. So next, the half-life is 1590, so that means this is the given h half-life value. How much? 100 gram sample yani at the beginning, so this is a naught at the half. How much will be left in 500 years, yani this is the time is 500. So this we substitute in the rule, a naught is 100 years, 2 power minus t is time 500 years, and h is half-life 1590, and we use this. So to calculate this, first to calculator, give like this, 500 divide 1590 in bracket, later multiply by 100, then you will get this answer. This is another example, a radioactive isotope whose name is this one. So 67 is the name of that isotope. It has nothing to do with the question, and later the word half-life is given again. That's why this is h 46.5. If we start any at the beginning 100 milligrams is there, so that is a naught. How many milligrams will be left after 24 hours, yani time is 24 hours, so how much will be present, yani a is how much. So again the same rule and substitution and same thing. Here this is a question given. The half-life, the word is there, that's why I will write a is a naught 2 power minus t over h. The half-life is 14.9, so that means h is 14.9. A 40 gram sample, yani at time t0, that is a naught. A naught is 40 gram. The question here stands, how much of the sample will remain after the time 48 hours? Given t is 48 hours. So let us substitute in this. A naught is 40, 2 power minus t is 48, h is 14.9, So this we have to do with the calculator. 2 power minus 48 divide 14.9 multiply by 40. That gives the amount of the after the time 48 hours. The answer for B. How long will it be? Yani time how much? 1 gram remains. Yani A is 1 gram. So we know the rule, same, minus T over H. And let us substitute A is 1, A naught as it is given in the question, 40 gram. This is A naught, sample and A naught. 2 power minus T, T is not given, H is given, that is 14.9. So we have to get now the time, yani how long, yani time. And the time is here, which is in the power. So we have to use the formula to transfer the exponential function to logarithmic function. First we should divide with 40. 1 over 40, so 40 over 40 cancel. 2 power minus t ala 14.9. Now use the formula to power is a log base other side. So this we will use now. So here the power is as you see minus t over 14.9 is a log base. The base is 2, other side is 1 over 40. So now minus t over 14.9, there is a rule log 1 over 40, this is equal to log 2, which we have to calculate by the calculator. From the calculator, if you find this, log bracket 1 divide 40 minus 1.60205 divide log 2 log 2 0.3010. So this minus and minus will get cancelled. T equals to 14.9 Zartvadili multiply 1.60205 divide 0.3010, 1.60205 divide 0.3010 multiply 14.9. That is the answer, 79.304. This is the answer. So like this we will get. This is the question on doubling time. In the question it is there, double in 37 years. The doubling time is D, 37. In 2008, yani that is time t0, yani we start the experiment in 2008. The population was this, yani this is P naught, beginning. Growing rate, it continues to grow. What will be the population in 15 years? The time is 15 years. So again we plug the all values. P naught is 5.7 here. 2, T is time 15 years. D is the doubling time 37 years. So we get this. This is the another formula to find out the compound interest. If we kept an initial amount in a bank, which gives the annual rate or interest rate, which is compounded n times a year. Suppose one time for a year, yearly. If it is n2, half yearly. If it is quarterly, then n4, monthly n12, daily n365. Then amount A in the account after t years time, t years. Initially it was p, the amount is, but after some time it will increase because you are adding interest, r%, that is r over 100 interest rate. Then after the time t, the amount A will increase. How much will be the amount after time t years? That is A, for which the formula is p into 1 plus r over n over nt. So we use this rule. So there we go. Suppose $2000 invested, and this is P naught, P N starting amount. This is compounded monthly, so N is 12. So this is R%. R is 7.125%. So 7.125 divide 100. How much will be that? If you see with the calculator, 0.07125. So that we will use all. P is 2000, 1 is same, R interest rate is this one, and N is 12 because it is monthly given, 12 on time T. So this is the rule. That is question A. The question B will be, how much is in the account after time T 5 years, and time is 5 years. So same rule we have to apply, but here in the place of time t we write 5 ne, that is 60, and find with the calculator. The question B is, how much is in the account after time 5 years. Okay. Question C, how long yani time, how much for the initial investment to be double, yani 2p, the p will become double, yani 2p. So here the A is 2p, here we write 2p. So there we go, here we write 2 into p, p is 2000. This is the rule, the p only, here 2p. So this p and p cancel. This is same like the previous answer A, and 12 into time t not given. So this is the simplification. And next after this we can use the rule, power equals to log base other side. So here the power is 12t, log the base is this one, 1.0059375. Other side is as you see it is 2. So there we go, 12t is a log, the formula is log 2 divide log 59375, and this we can do with the calculator. And after that dividing with the 12, yani here 1 over 12 will come, and you will get this answer. So this is another question. Here the thing is, how we start this. There are 2 into 10 power 4 bacteria present in a colony at the beginning. At the beginning, yani that is P naught. 8 hours yani time t is 8 hours later the population was yani p is 8 hours later this much. Determine k. So here as you see in the question there is no doubling time, there is no half life, but it is still it is growth yani. Then we use the rule p naught e power kt. So substitute 3 into 10 power 4, p naught is 2 into 10 power 4, this one, e power k not known but time 8 is t is 8. So this is 2 cancel, so divide 2. So we have to find the power k, 8k. Power is a log base is e, other side is 3 over 2. So power is a ln 1.5. Why log to the base e is ln. So if we divide by 8 both side, k is ln 1.58. This value we can find with the calculator. This is not log, it is ln. So if you go for ln 1.5, 0.4054 divide 8, which gives 0.0506. This is the question for A. And question for B. What was the population after 2 hours? After time 2 hours, what is P? So we have the same rule, P naught e power kt. P naught is at the beginning same, no change. E power k is already we get this 0.0506. Time t is given as 2. So this we have to find with a calculator like this. And what about answer C? Answer for C. We'll see answer for C. Answer for C. How long? Yani time how much? Population to triple. Yani A, yani P is with 3 P naught. 3 times. Triple yani 3 times. So we have the rule same. So P is 3 P naught and P naught. P naught, P naught cancel. E power K. And time T we don't know. Also we know k is we get the k, this is this value. So 3 is e power 0.0506 into time t. So again the rule is to convert to logarithmic function, power equal log the base other side. So power is here 0.0506 time, the log base is e, other side is 3. So we have to get this with the help of calculator. So here this is 0.0506 times t ln 3 because log to the base e, not log. So divide ln 3 divide 0.0506. This again we need to find with the calculator inshallah. Like this we will answer. So this is the end of the topic, applications of logarithmic and exponential functions. See you in the next video inshallah.